Hey everyone, today we're going to be talking about order of operations and evaluating expressions. Order of operations is probably a topic that you've seen before in either middle school or elementary school, and it's actually very fundamental to algebra because many times you're given an algebraic or numerical expression that you have to simplify, and you need to know which operation to do first. Evaluating expressions is a little bit simpler in that you're given either an algebraic expression or algebraic equation, and you're actually given some value for the variable, and you just have to substitute. So these are the two things that we're going to be covering today. And before we get started, as usual, we have a warm-up problem for you. And this is the scenario. You've won a door prize, and you have two options for you to get your prize. The first is a lump sum of $100 that you get immediately. And the second is a more incremental prize where you get $1 the first day, and after that, each day it doubles. So you would be getting $2 the next day, $4 the third day, $8 the following day, $16 the next day, and then $32 the last day, the sixth day. So if you add all these amounts up, you'll actually get $63 for option 2. So you're probably going to want to stick with option number 1 because $100 is a lot greater than $63. However, if you continue with the pattern for option number 2, you would actually end up with a lot more money than $100. So in the long term, option 1 is not that good, and for the short term, option 2 is not that good. Now we're going to try to learn some vocabulary regarding powers and exponents. So we have to identify the base, exponent, power, and factors. So as you might know, the 2 right here is actually considered the base. The 3 is considered an exponent. Now, when you have 2 raised to the third power, this together is actually considered a power. And each of these 2's is considered a factor. In the first example, we have 10 to the 5th. This really means 10 multiplied by itself 5 times. So if you want to simplify this, you would do 10 times 10 times 10 times 10 times 10, and you would get a final answer of 1 followed by 5 zeros, or 100,000. The trick with multiplying using powers of 10 is you can count the number of zeros and then just add them on after you write the 1 down. So that's how I did that problem quickly, if you were wondering. In example 2, we have 0.2 raised to the 5th power, so which really means 0.2 times 0.2 times 0.2 times 0.2 times one more 0.2. Alright, now because I don't really like decimals that much, I'm going to go with fractions. You might prefer the other method. You could actually simplify this using a calculator, but let's just try to see if we could do this by hand. So 0.2 written as a fraction is actually 1/5, and 1/5 raised to the 5th power is really 1/5 times 1/5. And again, you just keep doing this until you have 5 factors of 1/5. And this actually makes it a lot easier because we know that 1 multiplied by itself, no matter how many times you do it, it's just going to be 1. And actually 5 raised to the 5th power is actually 3,125. So your final answer will be 1/312. So you actually might know the order of operations already, but we're going to just recap for anyone who might not. We use the mnemonic device, please excuse my dear Aunt Sally, to help remember the acronym PEMDAS. And as you might know, P stands for parentheses, E stands for exponents, M stands for multiplication, D stands for division, A stands for addition, and S stands for subtraction. One thing that you need to remember when applying order of operations is that you always do math from left to right. And again, this is where a lot of students make a mistake when they're applying this rule. So let's try our hand at some examples using order of operations. The first says 6 minus 2 raised to the third power divided by 2. So you want to apply the parentheses. You actually want to simplify what's in the parentheses first. So we get 4 raised to the third power divided by 2. Now, according to PEMDAS, the next thing we should do is exponents. So 4 times 4 is 16, and 16 times 4 is 64. So we're going to get 64 divided by 2, which gives us 32. So that's the answer to the first question. Now, number 2 says 2 to the 4th minus 1 divided by 5. Now, although this might, appear to be kind of simple, it can actually be a little tricky. Notice, this is really saying 2 to the 4th minus 1 divided by 5. Now, if you put that set of parentheses there, it kind of makes a little bit more sense. So you should do what's in the parentheses first, right? Okay, so what is 2 to the 4th minus 1? 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So we get 16 minus 1 divided by 5. Now, 16 minus 1 is 15, and 15 divided by 5 is 3. So, again, 2 examples using the order of operations. Now, one of the other important parts of today's lesson is learning how to evaluate algebraic expressions when given values for the different variables. So let's take a look at example number 1. We have x squared plus x minus 12 plus y squared. We know x equals 5, we know y equals 2. So, all we got to do is substitute. Wherever we see an x, we're going to replace it with a 5. Wherever we see a y, we're going to replace it with a 2. So I'm going to get 5 squared plus 5 minus 12 plus 2 squared. Now, we can use the order of operations to help us simplify. We're going to look for parentheses first. We don't see any parentheses, so we're going to move on to exponents. We see a 5 squared and we see a 2 squared, so you could simplify those two terms. However, do not combine the entire numeric expression yet. So we get 25 plus 5 minus 12 plus 4. Remember, we must do order of operations from left to right. So that is why we didn't combine any terms yet. We see addition, so we could do that first. We see 25 plus 5, we get 30. 30 minus 12 plus 4. Again, we see subtraction and addition. According to PEMDAS, addition comes before subtraction, but that really makes no difference. We're going to do math from left to right. So we do 30 minus 12, which is 18, and 18 plus 4 equals 22. Now, the next example is a little bit more complicated, but it's still fairly simple. We have x times y squared divided by xy. If you want to actually write it out and expand it, we could say the numerator is actually xy times xy. Again, because that exponent is a 2. And we're dividing by xy. Please notice that we have the same factor in the numerator and denominator. This means that we can actually eliminate this repeated factor and replace it with a 1. So we have xy times 1, which is xy, and if you divide xy by 1, you just get xy back. Try this out with 2. If you did 2 times 1 and you divide it by 1, 2 times 1 is 2, and 2 divided by 1 is still 2. So you'll see that this works the same way for variables. We have xy, which we know is really 5 times 2, and that gives us 10. So we have the final answer, but we could also do it another way, which I'm going to show you real quick. We could actually start from the beginning and replace x and y with the numbers they represent. So we have 5 times 2 squared divided by 5 times 2, which gives us 100. If you do order operations, do what's inside the parentheses first, and then do exponents. So you actually get 100 first, and then you do division by 10. So we get 100 divided by 10, which is 10. We get the same answer, and again, both methods are correct. It's whatever you prefer, and I just wanted to highlight that this problem can actually be done a couple different ways. Before we conclude this lesson, I want to really make sure you understand a real-world application of the things that we've discussed today, which involve algebraic expressions as well as order operations. So when you get your first paycheck, you're going to notice that there are going to be some deductions on that paycheck due to taxes and other reasons. Now, imagine that you have a paycheck, alright? And we're going to just label this with P. Now, due to financial reasons, you actually want to save some of that money and put it in a bank account. So in this case, you're actually going to save up about 2/5 of the original paycheck. Since we are removing that amount of money from your original paycheck, we have to subtract it. Now, you should notice both of these terms have P variable in them. These are like terms, so you can actually subtract them. If you notice, this is actually a 1p, so 1 minus 2/5. You can find a common denominator, and you're going to get 5 minus 2 over 5, which gives you 3/5. And remember, we're going to keep the p along for the ride, so we get 3/5 p. This is how much money is actually left over after you put some of that money aside for savings. Now, the next thing that we want to discuss is evaluating our expression for our weekly wages of $40 and $100. How are we going to do this? Well, the great thing is we actually have our expression right here. We have 3/5 p. That's going to be the amount of money that we have left over that we can spend. So in our first case, we're going to have 3/5 times some amount p. In this case, we're going to substitute 40. And then in our second case, we're going to have 3/5 times another amount, $100. Now, doing the calculations, 3/5 times 40 gives us $24 that we can spend if our wages for that week are $40. And 3/5 times 100 gives us $60 that we can spend. And the $40 would go to savings. Again, this concludes our lesson, and if you have any questions, feel free to email me. Otherwise, I'll see you next time.